So for the first lesson of the first unit in physics, we're going to look at algebra. And the reason we're going to do this is just to brush up on your algebra technique and make sure that we're all on the same page here. A lot of times in physics, we have relationships between variables, or we're solving for a variable with an equation. And I want to make sure that we get a little practice before we dive right in. And then that way, you know what I expect in terms of how much work to show, and there's no surprises there. I guess when in doubt, always show extra work in my class. Otherwise, even though if you have the right answer, I cannot give you full credit, or sometimes not credit at all, if you don't show your work. So you always want to make sure you take that extra step in this class. All right. The first one I want to go over is number 6 here. Let me see if I can cover this up a little bit. So number 6 says, I'm going to go ahead and rewrite it down here. 5 minus x is equal to 6 plus 2. All right, so in this case, we want to get our variable. I guess if we have rules here for the notes, that would be get the variable off the bottom. And what I mean by off the bottom is out of the denominator, if it's in a fraction. And then the second rule would be get the variable alone. Sometimes the variable is x, sometimes it's not. And I think the big jump in my class, or in physics, compared to classes you've had in the past, is that a lot of times in math, they just use x, y as variables, and maybe area formulas have pi and r, and maybe also you have formulas that involve theta. But in this class, we're really going to use a lot more variables than that. So that'll be a change. Okay, so coming back to this, so the variable is not on the bottom, so now I just get to get the variable alone. I'm going to go ahead and push this 5 over to the other side. You can add a negative 5 to both sides. You can subtract 5 from both sides. I'm just going to go ahead and subtract 5. This is actually 8, so I might rewrite that as 8 minus 5. I'm doing a little more there than I normally would, but that's okay. 8 minus 5 is equal to 3, and 5 minus 5 is 0, so we have negative x equals 3. We don't want to know what negative x is, we want to know what x is equal to. So now we can do two things. We can multiply both sides by negative 1, or we can divide both sides by negative 1. I'm going to do that. Why can we do that? Because this is actually a negative 1 right there. So I'm going to divide both sides by negative 1. And the negatives cancel here, and so do the 1s, and they just become 1. I guess you can just cancel the negatives, and there's still a 1 there, whatever. So I'm going to rewrite it as x. Sure, there's a 1 out in front, but I don't need to write that. And this is this 1 on the bottom doesn't have to be written either, so we can just write that as this negative sign moves to the top. Write it as negative 3. All right. Good. All right, let's go ahead and go to the next one. Number 9 here. Do 9 and 10 because they kind of go together. So in problem number, let's see if I can move this up a little bit. In problem number 9, we have x over 20 is equal to 9. All right, so once again, get the variable off the bottom of the fraction. It is not. It is in the numerator, so we're good. Get the variable alone. It has this 20 underneath it, so I want to get rid of that. Notice last time when we had something being subtracted here, and we wanted to kick this over the other side, we had to, or we had a number here. We had to do the opposite of whatever this is. This is really negative x plus 5, so I subtracted 5. So since these two addition and subtraction went together, here to cancel out division, right? A fraction is really division. It's saying x divided by 20. We can just go ahead and multiply. And we're going to multiply both sides by 20 here. So I'm going to go ahead and show that just like so. And we can go ahead and cancel, because the 20 on top cancels the 20 on bottom, right? This is just one giant fraction. All right, and so we're left with just x here, and 9 times 20 is equal to 180. All right, problem number 10. 10 looks a little bit like 9, but it's a little bit different. Definitely going to be a different answer. Okay, so now it's saying 20 divided by what number is equal to 9? All right, so we know 20 divided by 2 would be 10. So we're expecting something close to 2, right? Yeah. So it's gonna be something a little smaller than 2, right? Okay. Anyways, let's give it a try. That's my guess. All right. So I want to get the variable off the bottom, right? That's my first thing I want to do, and because it's in the denominator here. So to do that, what I'm going to do is I can do two things, right? I can solve this two ways. So I'm going to show you two methods. The first method, I'm going to go ahead and cross multiply. So I'm going to rewrite this really quick. This is really 9 over 1. So what I'm going to do here is I will cross multiply like so. Right, so we have 20 times 1 is equal to 20. I'll just go ahead and write that on one of the sides. And 9 times x is equal to 9x. Then I can go ahead and divide. Move this up. Sorry, this is getting hard to see. Go ahead and divide both sides by 9. And I have x equals 20 over 9. 9 goes in there. Well, it's actually a little over 2, I guess, under 2. It goes in there 2 times and then a little bit more. So I'm going to have to get my calculator for that. I got that right here. 20 divided by 9, 2.22. All right. So how many numbers should I write here? I don't know if you can see that, but it's 2.2 repeating. I guess you can write the 2.2 and then put the little bar above the 2. I just go ahead and round and go out usually 2 or 3 past the decimal point, and that's pretty fair. So there's no rounding required here, so I'm just go 2.22 because the third 2 there, or the fourth 2, the third 2 after the decimal means that it stays the same, all right? Because it's got to be, if it's under 5, then it doesn't move up. So I'm just going to go ahead and write 2.22 as my answer there. All right, and let's try the second way, right? I said there was 2 ways that I would approach this, and let's see if it looks any different. So the second way, I have 20 over x is equal to 9. Now I'm going to multiply both sides by x. Got to get the variable off the bottom. So when I do that, I can now, right, I now have this. I can cancel these x's right here, and I'm left with 20 is equal to 9x. Now I can go ahead and divide both sides by 9. See how I'm showing my work, and that's what you want to make sure you're doing. Cancel there. I forgot to write the canceling here, but you get the idea, right? I'm showing the fraction. That's what I want you to show. Whether or not you draw these lines, that's a different story, but I like to do it because it's fun to cancel things. 9 goes into 20. We just saw that, or 20 divided by 9 is equal to 2.22. All right, so 2 ways to do it. One, we cross multiply. The other one, we just multiply both sides by x. And either way is fine, whichever way you like more. And I guess I can show you I could have also wrote that as 2.2 repeating, and that would have been fine as well. All right, cool. Let's go to the next problem. Okay. So after that, I'd like to work through problem 13. I'm just picking some ones that I know students have struggled with in the past. So let me go ahead and rewrite problem 13. Looks like we have 5 divided by x minus 7 in parentheses is equal to 10. The reason this is in parentheses is just to show you something here, that when we want to get this off the bottom, it's really the same as the last problem where we could cross multiply, or we can multiply both sides by x, but we can't just multiply by x because of this minus 7 here. So we have to multiply by x minus 7. So yeah, we're going to multiply by this whole expression here. All right, so what that's going to look like then is x minus 7. Let me rewrite. I guess I could have wrote it up there. I was just kind of running out of room. So I'm going to write multiply both sides by x minus 7 like this. Let me get my green marker just to show you what I mean. So I'm multiplying both sides by this, right? That's all I'm doing. Okay, so over here then I can go ahead and cancel these two x minus 7s and rewrite or simplify, right? So I have now 5 is equal to, we have to be careful here. When this, I'll go ahead and write it out. When you have this, you have to distribute this 10 through to both of these. And so I'm going to go ahead and write this as 5 equals 10x minus 70. Then we're going to kick the 70 over to the other side. This is being subtracted, so you should all be saying, okay, so we're going to add that, right? And that will cancel these. So we'll add 70 to this side. 75 then is equal to 10x. Whoops. Jeez. 10x. And then divide both sides by 10. Cancel, cancel. And we're left with x is equal to 7.5. I did a little switch there. I moved the variable over to the other side. I just do that because usually I like reading x equals 7.5, but I could have left it like 7.5 is equal to x. That's still fine. I don't know, it's just the way we normally do things is like that. So, all right, so there's number 13. Now let's go ahead and look at number 16, which if I'm going too fast, you can always pause it, and if I'm going too slow, you can, and this is on YouTube, you can always speed it up. So then that way, yeah, it's just a little quicker for you. All right, so here we have x equals 1 over 1/4. So we hate fractions in our fractions, right? Nobody likes to see that. So what do we do with that? Well, what this is saying, right, let's remember what a fraction says. For instance, if I had this problem, x equals 4 over 2. This is saying 4 divided by 2, or 2 goes into 4 how many times? How many times does 2 go into 4? Well, 2 plus 2 is 4, so it goes in there 2 times, right? So that's equal to 2. How many times does a fourth go into a whole? All right, well, that makes more sense then. That goes in there 4 times, so our answer is 4. So you can see what we're doing here, right? This is like $1, and you got a quarter down here, right? How many times is a quarter going into $1? And it goes in there 4 times, so that's our answer. But there's another way to think about this, and it's what you do with this is you do something called multiplying by the reciprocal. So what you have here then is you take this 1/4 and you flip it and then multiply. So what I'm saying here, right, and 4 times 1 is 4, and 1 times, this is just a 1 here, right, is 1. So we get 4 over 1, which is still 4. So either way, it works. But what I'm saying there is that then you have to know what a reciprocal is, right? So, and that's a good thing to know. All right, so we have 1/4, right? And then our reciprocal would be 4 over 1 is what we're saying there. That's what we did there, right? Let's do it. Let's look at another one, right? What if I had 1/7? What would the reciprocal be? Well, you would say 7 over 1. What if I had 3/7? What's the reciprocal? Well, then it would be 7 over 3. So we're just flipping, and we multiply that. So we multiply by the flip, or we multiply by the reciprocal. This is the reciprocal of that. This is the reciprocal of that, right? So they're, yeah, that's how that works. So anyways, hopefully that makes sense. And that does come up a decent amount where you get a fraction in your fraction. And a fraction on top is not that bad, but a fraction on bottom, you have to multiply by the reciprocal. What if I had a fraction on top? What would happen there? I guess I can show you that really quick right here. So if I had, say, x is equal to 1/2 over 2, right? This 1/2 would, this 2 would just go to the bottom, and the 1 would stay there. So I'd end up with x equals then 1, right? The 1 stays on top, and the 2 gets to go to the bottom. So 2 times 2, which is 4. So I would get x equals 1/4. All right. Maybe I could have picked a better problem for that, but let me see. What if I would have said instead y is equal to 1/4 over or 1/2. Sorry, that's a 2 over 1/4, right? And so this is like saying, well, how many times does a fourth go into a half, right? And you would say, well, there's 2/4 and a half, so the answer would be 2. But let's look at what happens there with the fractions, right? So, okay, so on top, right, we said the 1 gets to stay there and the 2 gets to go to the bottom, right? Okay, so the 1 stays on top, 2 goes to the bottom, and with the 4th on bottom, we multiply by the reciprocal. The reciprocal of 1/4 is 4 over 1, so the 4 goes up here, and the 1 goes here. Check that out, right? And that's, you're like 4 times 1 is 4, 2 times 1 is 2, 4 over 2 is 2. See, it works. So all the fractions, that's how they behave, right? Because we know common sense, there's how many fourths are in a half? We know 2, right? But when you use the fraction rules, for fraction on top, it just gets kind of shifted to the bottom, and fraction on bottom, you have to multiply by the reciprocal. They work out, and you get the same answer. So I just want to show you that, and that's a good example. All right, let me go ahead and move to the next problem, which is problem number 21. Okay, burning through some paper, not using the backs of these pages, and hopefully I didn't want the marker to come through. All right, 21 says, it's right here on the back, 5 over 3x plus 17 equals 8. Let me rewrite that. 5 over 3x plus 17 is equal to 8. All right, so once again, we get this fraction hanging out on the bottom, but you might say, okay, well, let's get that fraction off the bottom. The only problem with that is we'd have to multiply both sides by 3x. And if you multiply this by 3x, that's cool, right? That would work. You'd get 5, but you have to multiply this by 3x too. So the 3x would have to go here and have to go here, and then you'd multiply this by 3x. So what would happen is you'd end up with a 3x here and a 3x here. So I don't like starting this by multiplying by 3x, right? So there's almost like a rule then before the first rule, which is get this x off the bottom, and that would be just to simplify, right? So maybe if I added another rule here, a rule 0, it would be simplify, right? And I guess what I'm saying there is, let's make this a little simpler before we get this variable off the bottom. So what could make it simpler? Well, let's get rid of the 17. Let's kick it over there. So we're going to say minus 17 minus 17. So 8 plus 9 is 17. So if I subtract this, I'm going to be left with negative 9. These two will cancel, and I'm going to have 5 over 3x is equal to negative 9. All right, very good. Now we can go ahead and multiply both sides by 3x, or we can cross multiply. I'm going to cross multiply this time. I didn't done that in a while. There's a 1 right there, so I'll go ahead and multiply the 1 by 5 and the 3x by negative 9. Make sure you only multiply the negative sign once, so the 1 doesn't get the negative. So 5 times 1 is 5. 3x times negative 9 is equal to negative 27x. We're then going to divide both sides by negative 27 because our variable is now off the bottom, but we got to get it alone, right? So this is being multiplied, negative 27 times x. So to get rid of that negative 27, I'm going to divide by negative 27. So then I can cancel here and the negatives as well, and divide this side by negative 27. So my answer there is x equals negative 5 over 27. Now, could I also have written that as a decimal? Sure. This doesn't really have to be simplified in my class further than that. Decimal answer is fine, but if you really, or I mean a fraction answer is fine there. If you really want a decimal answer though, I think you can see it there hopefully. It says negative, it says 0.185, but I forgot my negative sign, so negative 0.185. All right, that's good, 21. Let's go ahead, I think we got one more, and then that would be number 22 here. So down at the bottom of the back of the page, there we have this problem right here, and okay, so let's look at that. First of all, what's different about this is, well, we have an exponent, right, with the number 2, so we're going to have to square this 1/4, so 1/4 times 1/4, which is going to be 1/16, so that's not going to be a problem. But it says solve for x in terms of f. In terms of f just means that the variable f is going to be in our answer, and we're not going to be able to get rid of this variable f, right? So we're going to get x alone on one side and then solve in terms of another variable, which is fine because sometimes there's an unknown we don't know and it's just going to stay in there. So we're writing this expression of for x, right? So, okay. So let's go ahead and rewrite this problem really quick. 22, or I need to see it here, so I'll rewrite it. F times 10 times 10 divided by 1/4 squared. All right, so before we do any multiplying by the reciprocal with this fraction, let's go ahead and square it, right? So what is 1/4 squared? Well, that's just the same as 1/4 times 1/4, right? 1 times 1 is equal to 1, 4 times 4 is equal to 16. So multiplying fractions isn't very tough, but adding and subtracting them is a little harder because you got to have common denominators, but we don't have to worry about that. We're just multiplying. So multiply the top across, multiply the bottom across, and we're left with that. So I'm going to go ahead and rewrite now. Also, 10 times 10 is 100, so I get 100f is equal to 1/16, right? Okay, then we remember our rule about a fraction on the bottom. We multiply by the reciprocal. The reciprocal of 1/16 is 16/1. So we're going to go ahead and say x then is equal to 100f times 16/1, right? And so we have 16 100s, which is like if you're playing Monopoly, 16 $100 bills, you would have 1600 or 1600 times f. And that's it. So there we go. All right, I'll have another video which goes over some more complicated algebra problems, but this is the first one, and hopefully it made sense.